All right, so now we'll talk about the derivatives of inverse trig functions, and let's start with review of inverse trig. So if we have sine of pi over 6, we know that equals 1/2, and inverse sine of 1/2 equals pi over 6. We can also say arc sine of 1/2 is pi over 6. But we have to be careful that if it is sine of 5 pi over 6, that also equals 1/2. Here we have pi over 6. That's a 30, 1, 2, radical 3. Sine is 1 over 2. With 5 pi over 6, it's also a 30, 1, 2, radical 3. And we're also going to have 1/2. But when we do inverse or arc sine of 1/2, we still have pi over 6. And this is just showing that the range of inverse trig functions is restricted due to we don't want to make it a function. We can't have more than one y value for each x value, and we'll see that in the next example. So if we're evaluating an inverse function of 1/2, let's rewrite it as cosine of some angle equals 1/2. And we know that cosine is x over r. So when we draw the triangles that or the angles that have a positive x value, that's going to be on the right. X is 1, radius is 2, and that must be the radical 3. But inverse cosine can only have values from 0 to pi. So that means we must take this one, not that one. And we'll say that theta is this angle, and that's opposite of radical 3, so it's pi over 3. All right, try the next two. Pause the video, and remember that arc cosine, arc cotangent, and arc secant all have this range. Then arc sine, all the other three, arc tangent and arc cosecant, all have this range from negative pi over 2 to pi over 2. Okay, pause the video and try these. Sine of some angle is radical 3 over 2. Sine is y over r. So we need a y value that's positive, and that will put us here. Positive y value. Radius is 2, and the x is 1. So we see that if we only take this range, we're going to have a pi over 3. So theta equals pi over 3. Tangent of some angle equals 1. Let's make it a fraction, and we'll say it's y over x. But this could also be a negative over negative. Here with a radius is always positive, so y must be positive. With y and x, we can change both signs. And that gives us two angles. Positive y, positive x. Negative y, negative x. But arctangent has a range, the same range as arcsine, so we're only going to look right here, and that means we ignore that one. So the angle is pi over 4. Okay, let's get to the calculus. We know that the derivative of an inverse function is 1 over the derivative of the original function. And so what if we want to find, so just remember that, and we want to find f prime if f of x is arcsine of x. So remember that. Let's deal with this. Let's think about what this means, and then we can talk about finding the derivative of an inverse. So we are saying f is the inverse. We want the derivative of the inverse. If we want the derivative of an inverse, we're going to be using this relation. Let's think about this like we just did. Sine is, in this case, sine theta is going to be equal to x, and that's what that says. We know that that is true, so we could represent theta as having a y value of x, a radius of 1, and then we can use the Pythagorean theorem to find this. So we have whatever that is, a squared plus x squared equals 1 squared. So a squared is 1 minus x squared. And we know that that's 1 minus x squared. All right. Then we want to find f prime. So let's think of it like this. I think the f's are going to be confusing, so why don't we do this? We want the derivative of arcsine. The derivative of an inverse is 1 over the derivative of the original function. So we could think of it like that. Remember that if there's an x there, we're really, this is a y value of this function, so we need an x value of that function. Let's find the derivative of sine, and that's cosine. But then we have, we want to represent this in terms of x. So now we need cosine of theta, which is going to be this over 1. All right, and we can just write that as, so the derivative of inverse sine is this. Arctangent and arcsecant can be found in a similar way. Let's just look at the formulas, and we'll just have to memorize the formulas. So, if f of x is arcsine of x, then the derivative is 1 over 1 minus x squared. So we just saw that. If we have arctangent, then the derivative is 1 over 1 plus x squared. Arcsecant is 1 over absolute value of x, x squared minus 1. And then we don't see the cofunctions very often. We'll go ahead and write them down. They're easy to remember. Arc cosine, so the derivative is negative 1 over 1 minus x squared. And we just make these negative, and those would be the derivatives of the cofunctions, arc cotangent, negative 1 over 1 plus x squared, arcsecant, negative 1 over x squared minus 1. All right. Look for some patterns in these to help you memorize them. And so it's easy to memorize this way. Really, all you have to do is memorize these three. And what I like to do is just remember tangent is not a radical, does not have a radical. And I remember that arcsine and arctangent start with a 1, arcsecant starts with an x squared, and that should help you remember a few characteristics. So let's use these. All right, find the derivative. Since we're just using a formula, we're just going to have something more involved, to present a challenge. So here we have to use the chain rule. And we look at arcsine. That's going to be 1 over radical 1 minus 2x squared. So this is the derivative of arcsine, leaving 2x the same. Then we have to multiply by the derivative of 2x. That's the chain rule. And we can just put the 2 on top. Find f prime. Go ahead and pause the video and try that. So arcsine is 1 over radical 1 minus the argument. So we just copy the argument there. And then we do the derivative of that, which is 1. We could expand that and combine like terms. We'll just leave it as it is. Okay, and tangent, we just remember the pattern for tangent, the formula, 1 over 1 plus x squared. So here we'll have 1 over 1 plus the argument squared, 3x plus 1. And then we have to do the chain rule, so we'll get times 3 there. Also remember, you could have this notation or that notation. Okay, pause the video and try that one. One over 1 plus the argument squared. The argument is x squared plus x. And then we have to multiply by the derivative of that, 2x plus 1. Usually we would simplify that, but to keep the video short, we'll just focus on the calculus, and then you can practice the algebra in your assignment. So arcsecant, we just have to use the formula for arcsecant, the derivative, and here we have the formula. So we just have to memorize that. 1 over the absolute value of the argument times the square root of the argument squared minus 1. And the argument is 5x, so we have 5x, 5x. This is the derivative of the outside, leaving the inside the same. We have to do the chain rule, so we get a times 5. Pause the video and try that one. One half x, 1/2 x, and then we have to multiply by the derivative of 1/2 x. Alright, find the derivative. We have to now use the product rule. Remember that we'll never have, this is never a product. We don't want to read this as being arc cosine times x. It is x times arc cosine of x. So we have here's the pattern for the product rule, and we have the first times the derivative of the second, so that's arc cosine. Arc cosine is the same as sine, 1 minus x squared, but we make it negative. And then we have the second times the derivative of the first. So there's not much to simplify. We could just put the x up there and move the radical. Okay, find the derivative of that. Pause the video. So we have a product. And we have the first times the derivative of the second. Arctan, that's 1 over 1 plus x squared. Then we have the second, arctan, times the derivative of x plus 1. X plus 1 equation of the tangent line. And now it'll be the same as every other time we found the equation of the tangent line. We just have a different formula for the derivative now. So we still just find the slope and then use the point slope formula. The slope is going to be the derivative, and we have the derivative of arc sine, so we have 1 over square root 1 minus the argument squared times the derivative of the argument. That's the chain rule. We need to evaluate it at 1/4. So 2/4 is 1/2. 1/2 squared is 1/4. 2 over square root 1 minus 1/4. 2 over square root 3/4. And we'll end up with 2 over radical 3 over 2. And we do the reciprocal, we'll have 4 over radical 3. Point slope, y minus a y value is mx minus the x value. The slope is 4 over radical 3, and the x value is 1/4. The y value is arc sine of 2 times 1/4. That's arc sine of 1/2, and we saw that earlier is pi over 6. And we're going to distribute, so the 4 will cancel. We get 1 over radical 3. Let's add pi over 6 to both sides, and if we are going to graph it, we're going to have y is approximately 2.31 x minus 0.0537. And we can stop there.